Welcome to our first video on chemical bonds, and in this video we're going to talk about covalent bonds. Now, atoms will become non-reactive or inert when they have a full valence or outer electron shell. This can be accomplished either by sharing their electrons or transferring them from one atom to another. Now, those electron shells will always take a specific number of electrons. The first shell can only take 2, and the subsequent shells can take 8. Now, covalent bonds will result from the sharing of valence electrons, hence the name covalent. It's part of 2 valence shells. Now, the electrons are always shared in pairs, one coming from each of the 2 atoms that's involved in the bond. Let's have a look at some examples of covalent bonds. We're going to start with the simplest atom, hydrogen. Now, covalent bonds can be formed between atoms of the same type, as we're going to look at first. Each of these hydrogen atoms has a single electron in its first shell, so it needs one more for the shell to be full. It can get that by sharing the one it has with another hydrogen atom, so that the electrons become a part of both of the outer shells. Now, in our second example, we're going to consider bonding atoms of different types. In this case, hydrogen and nitrogen. Now, nitrogen has 5 electrons in its valence shell, so it needs 3 more for the shell to be full. Hydrogen only has 1, so we'll need 3 hydrogens to each share their single electron with the nitrogen. Now, how many electrons can an atom share? Well, that depends on how many it has and how many it needs to complete its valence shell. Assuming each atom donates 1 electron to the bond, we've made a single covalent bond. If each donates 2, it will form a double bond, as in the case of this oxygen molecule that you see over here, and it could even donate 3 to form a triple bond. Remember that these are electrons from each atom, so they're always in pairs. Now, atoms can also share electrons with more than one other atom at a time, as in the case of this carbon dioxide molecule, with carbon, which has a valence of 4, can form a double bond with each of the 2 oxygens. Electrons aren't always shared evenly between the atoms in a covalent bond, and it depends on the electronegativity of each atom, that is, how strongly they pull on the electrons. Consider a covalent bond like a tug of war, with the electrons being the flag on the rope. If the atoms have the same electronegativity, they exert the same pull on the electrons, and so they'll be evenly distributed between the atoms. This results in a nonpolar bond, and this occurs between atoms of the same type, but also atoms of different types with a similar electronegativity, like carbon bonded to hydrogen. If, on the other hand, one atom is more electronegative than the other, then the tug of war will be more like a football player against a kindergartner. The electrons will spend more time around the more electronegative atom because electrons are charged, and this will result in the electronegative atom gaining a partial negative charge, while the other ends up with a partial positive charge, and this results in a polar covalent bond. The most common examples of this in biology is when we have either oxygen or nitrogen, both of which are very electronegative, bonded to hydrogen, although these are not the only examples of polar covalent bonds. We're going to finish this video with a comparison of molecules and compounds. Now, covalent bonding always forms molecules, but those molecules may or may not be compounds. In order for something to be a compound, there have to be 2 or more elements involved. So in the examples we have here, our molecular hydrogen is a molecule, but it isn't a compound because there's only one type of atom. In the ammonia, on the other hand, we have 2 different elements, nitrogen and hydrogen, and we have a specific ratio of 1 nitrogen to 3 hydrogens. So in this case, we have both a molecule and a compound. Thanks for watching, and please make sure you check out the other videos available in this section.